Well, hello pre-calculus students and seekers of general truths. In this video, we will do some more examples on limits of sequences, and this is really getting you familiar with working with notation. So here we have some sequences that are defined explicitly. So what this means is that if we want to know what a sub n is equal to, we're going to use these expressions here. This is sort of a function, right, for us to figure out what a sub n is. So a sub 1 in this case is equal to 4 times 1 plus 2 divided by 1, right? So that's 6. A sub 2 is going to be equal to 4 times 2 plus 2 divided by 2. So that's 8 plus 10, so that's equal to 5. Okay. So as an example here in this first one, a sub n, if we were to keep expanding it, we're using this formula to plug in some numbers and figuring out what the sequence will be equal to. Now, what we want to do here is figure out, will this sequence converge or diverge? And when we have these functions, it's very straightforward and nice for us. So we simply take the limit as n approaches infinity of the particular explicit definition that we're given. So 4n plus 2 over n. And we take the leading terms in the top and the bottom, right? So this is the limit as n approaches infinity of 4n over n, which turns out to equal 4. Okay, so if we were to continue just putting in huge numbers into here, let's say a trillion, ultimately the fraction that we get would be getting closer and closer and closer to 4. So let's do a few more here. So for the second problem here, you can see the same thing, that the limit as n approaches infinity, take the leading terms in the top, that's the term with the highest power, and leading term in the bottom, divide those two, and we know that the limit here as n approaches infinity of, let's call this b sub n, right, of b sub n is going to be equal to 6 to the 6n to the 4th over 3n to the 4th. So that's just going to be 6 over 3, so that's going to approach 2. Okay. Here in the third case, and let's call this sequence c sub n, right? So the limit here as c sub n gets very, very large, or as n gets very, very large, we look at the leading term, which is 137n squared over n cubed. So we can factor it out and cancel out an n squared. So this is the limit as n approaches infinity of 137 over n. And we can see here that when the power in the bottom is larger than the power in the top, then this sequence will converge to 0, because as n gets huge, the overall results get closer and closer. The fraction gets closer and closer to 0. Okay? So, and then one more here for us to think about. This is 1/2, right, to the nth power. So I'll call this series d sub n. And another way that we could represent this is 1 over 2 to the n, because 1 to the n is just equal to 1. And we can see here pretty quickly that if n is a large number, 2 to the billionth, then 1 divided by 2 to the billionth is going to be 0. Okay? So hopefully you get some sense of quick practice here in how do we look at an explicit definition of a sequence and determine whether or not each of its terms is going to be convergent or divergent, and what it converges to. Again, if you see that this limit here approaches infinity, or there is no limit, then we say that the sequence is divergent.